Everything on this topic is about slope-intercept form. Here's what you need to know. Slope-intercept form is y equals mx plus b. The b is the y-intercept. That's where the graph is starting on the y-axis. So the big thing to remember is that we start here at the y-intercept, right? Always, always, always. And then this is the slope, right? This is the change that's happening to the graph. So when we graph it, we actually start here, and then this tells us how to move, how to change. Okay, we can also remember that slope is rise over run, right? That's a great tool that we can use to graph. Okay, so we can use this to graph lines, but we can also use it to find the equation of a line, to find the equation in a table. It all comes back to this idea that in y equals mx plus b, this is the start, and this is the change. Okay, so let's take a look at some of the different question types on the final that you can use this knowledge for. Here, this is y equals mx plus b. So here, my b is my y-intercept. I'm going to the y-axis. I'm graphing at -1. And then my slope is -2/3. So I'm going to go down 2, because this is my rise. So it's negative. I'm going down 2 and right 3. So I'm going to go down 2, right 3, and this is my line. In this one, notice whenever I have y equals, you're going to want to just say, oh, that's y equals mx plus b. Where's the plus b? Uh-oh, that's because it's a +0. So we're still starting here. Start here on the y-axis, start at 0. And then this is my slope. What I do is I make it into a fraction, right? I put it over 1. I'm going to rise 4 and run 1. 1, 2, 3, 4, run 1, just like this. Okay, here, this is still y equals mx plus b. My b is 2. I'm starting at the y-intercept. What's my m? Oh, this is an invisible 1. Let's make it into a fraction. That's rise over run. I'm going to go up 1, right 1. And there it is, something like this. Okay. Now, moving on, I can do the same thing here. Now I'm writing an equation of a line. Well, I still just need to know the two pieces of information, the starting point and the slope. So my starting point is right here. It's at this number, -1. And then my slope, what I'm going to do is find 2 points. Look, here's one, and I'm looking for another lattice point, like this. See how this hits the grid? Right here. So now my rise is 2, and my run is 3. So my rise over run would be 2/3. Okay, and here it is in my format, y equals mx plus b. Okay, now here's one that's not y equals mx plus b. There's another way to graph this. You can graph it using intercepts, totally fine if you prefer that, but what I want to show you is that you can choose to use this knowledge. You can just rearrange this equation so it looks like y equals mx plus b. How would I do that? Let's think about it. If I want it to look like this, I need the y to stay right where it is, but everything else needs to go to the other side of the equation. So I would start by subtracting 5x from both sides. That would be -2y equals, look, this would be -5x plus 8. Now, I would divide by -2. Why? Because look, I'm trying to get y by itself. That's what I want. I want y to be by itself. So I'm just solving just the way I would solve an equation. Y is being multiplied by -2. I'm dividing. This is a negative divided by negative. That's a positive. 5/2 would give me a decimal. We don't like decimal slopes. We're just going to leave it as a fraction. And 8 divided by -2 is -4. Now I can just graph this. Start at the b, start at -4. My rise is 5, my run is 2. 1, 2, 3, 4, 5, 1, 2. And here's my line. Okay. Lastly, you can even use this same knowledge, y equals mx plus b, in a table. Now listen, you can only use it in a linear table. How do I know this is linear? This table has an adding and subtracting pattern. Okay. Exponential will have a multiplying or dividing pattern. This one is linear. I can look at the table and see that that's what's happening. Okay, so exponential has a different function. That's right. That's where you have the start times the change to the power of x, right? If you remember that. But that's not y equals mx plus b. This one, though, for linear, we do use y equals mx plus b. So I'm going to find, right? Remember, I'm going to write the equation. And the equation is going to have the starting point and the change. So let's find the starting point. The starting point is where x is 0, right? That'll be the y-intercept on the graph. So that's +13. And what's the change that's happening here? I notice that what's happening is that I'm subtracting 5 each time. So the change is -5. So again, starting point, change every single time. Using all this knowledge, you can go ahead and answer these questions on the practice final.